So today, we're going to talk about a really powerful technique for making smart decisions when the future is, well, a total mystery. It's called the Monte Carlo Simulation, and it's an incredible way to turn all that uncertainty into a real advantage. Let's dive in. You know the feeling, right? You've got two different places you need to be, and it feels like there's just no way to make it to both. It seems impossible. But what if you could actually calculate your chances? That's exactly the kind of problem we're going to unpack today. Okay, so let's meet Alex. He's got a classic dilemma. He wants to hit his friend's party at 6, but he's also got to make it to a coworker's dinner by 8. The real kicker? He's leaving work at 5, and he's up against the one thing you can never, ever predict: city traffic. So what's Alex supposed to do here? Does he just pick one and skip the other? Or does he just guess and hope for the best? Yeah, when you can't calculate one perfect answer, it really feels like you're just taking a shot in the dark. But what if there was a better way? You see, the schedule itself isn't really the issue. The real problem is the uncertainty. The drive to the party, that could take anywhere from 30 minutes to, a whopping 50 minutes. And the next leg, to the dinner, another 25 to 40 minutes. We're talking about a huge range of possibilities, and that's where things get tricky. So to solve a problem that feels like a total gamble, we're actually going to turn to a method with a very appropriate name. It's a technique named after the most famous hub of chance and probability on Earth, the Monte Carlo Casino.
And here it is, the Monte Carlo Simulation. Now, that sounds complicated, but here's all it is. It's a way to use a computer to run the same scenario over and over and over again, thousands of times. By throwing a bit of randomness into the mix each time, you can solve problems that are just way too messy for a simple formula.
A great way to think about it is a coin flip. If you flip a coin once, the outcome is totally random, right? 50-50 shot. But what if you flipped it 10,000 times? Well, a very clear, very predictable pattern emerges. You're going to get pretty darn close to 50% heads and 50% tails. The Monte Carlo method harnesses that exact same idea. From tons of random events, a predictable pattern always shows up.
All right, so how do we apply this to Alex's problem? Well, instead of trying to guess the one perfect outcome for his night, we're going to have a computer live out his entire evening thousands of different times, each with a different roll of the dice for traffic. All we have to do is give the computer a few simple rules. For each simulation, first, pick a random travel time to the party. Second, make sure Alex stays for 45 minutes. Third, pick another random travel time to the dinner. And finally, if he gets to that dinner before 8 p.m., we'll mark that down as a success. Simple as that. Think of it this way. Every single one of those simulations is like a peek into a different possible future. In one version, traffic is a dream, and he's early for everything. In another, it's a total nightmare, and he's running super late. We're essentially exploring thousands of these potential realities to see what's most likely to actually happen. So we did it. We ran the simulation 10,000 times. We let the computer experience every good, bad, and ugly traffic scenario for Alex's evening. After all that, what did we actually find out?
After crunching the numbers on 10,000 possible versions of his night,
The answer becomes surprisingly clear. Alex has a 73.4% chance of making it to both the party and the dinner on time. See, he's not just guessing anymore. Now he has a real, concrete number, a nearly 3 in 4 shot at pulling it off. But here's the real magic. That one number, it's great. But the true power of this is understanding the full range of what could happen. It's not just about the probability of success. It's about truly knowing your risk. And now we can see the whole picture. On an average night, Alex strolls into dinner around 7:32. Best case scenario, he gets there at 7:15. But here's the crucial part. On a really bad traffic day, the worst case scenario has him arriving at 8:15. Now he gets it. He can see his risk and maybe even plan for it, like sending a text if he hits a jam. Look, this is so much bigger than just figuring out Alex's schedule. This whole idea of turning confusing uncertainty into clear, actionable understanding, it's used to make some of the most important decisions in the entire world.
I mean, the applications are just everywhere. Finance pros use it to model investment risks. Engineers use it to see if a building can survive an earthquake. Climate scientists use it to forecast global warming. From designing new medicines and calculating the odds of a successful space mission to optimizing a company's supply chain, it's an absolutely critical tool for navigating the unknown.
So, if you take one thing away from this, let it be this. Monte Carlo simulation transforms fuzzy uncertainty into real understanding. When you can't predict the future, you don't have to just guess. You can simulate it thousands of times and find the powerful patterns hidden inside all that randomness.
And that kind of leaves one last question for you. From a career change to a financial plan, or even just planning your next big project, what uncertain future in your life could become a little bit clearer if you could simulate it, not just once, but thousands of times?